Okay, so we're going to start looking at verifying inverses, which is something that we did at the very beginning by checking particular values. But there's another way to do it just by looking at the equations without having to plug in numbers into both of the functions and determining if they are inverses. In this particular case, we're going to see something just a little bit different. So what we're going to do in this case is we are going to use the functions, and we're going to see some kind of new form. Now, what I want to do is I want to point out something as we start going through this part. Um, and here we go. So notice here that we have f of g of x equals x and g of f of x equals x. Now, these are written a certain way, so you'll notice that they are written a certain way. You can see that it says f of g. A lot of students think of this as fog and goff because it looks like an O. It really isn't an O. Remember that we've dealt with functions where we have multiplication, we've had division, we've had addition, we've had a subtraction, we've had all of that stuff that we were dealing with the functions. And I thought I wrote all that stuff down, but I don't think I did. So I'm going to come down here and I'm going to do that. So we've had f of x plus g of x. That just means we're adding. Of course, subtracting is the same thing. We've had f of x times g of x, and we had f of x over g of x. Now, we've written them different ways. We did f plus g of x. This was from the last section. We've had f times g of x, and we've had f divided by g of x. So just different ways to write them. Now notice this is multiplication. That is a dot there. When we're looking at fog, notice it looks like that. It's f of g of x. It really isn't an O. It's like an open circle as opposed to a closed circle. I drew it a little bit bigger so that it wouldn't look like a closed circle there. But these are different, so they are not equal to each other. This is not multiplication. Okay, this is multiplication. This means f of g. Now, what does f of g mean? So it's actually probably the easiest thing that we're going to do today. So I want to make sure with this whole assignment that you understand what we're going to kind of do. So when I want to find f of g of x, that just means what I'm going to do is I'm going to plug in g, this right here, into all the x's. So another way to write this is f of g of x, which is really what's happening. Remember, if we write f of 2, that just means we plug in a 2 everywhere there's an x. If we plug in f of w, that means we're going to plug a w in everywhere there's an x. If I do f of g of x, that means I'm going to plug in everything in g of x into where this x is right here. So this part right here equals 5 times 1/5 x plus 3/5 plus 3. So notice I just plugged in, here's where my x is, I plugged in g of x into that part. I'm then going to multiply everything through, I'm going to distribute. So I get just x, I get plus 3 plus 3 in this particular case. And I think, does it say that they are intervals? Oh, sorry. I should probably be on the problem that I'm working on. Just want to make sure I have it all written correctly. Give it a chance to kind of pop up. Okay, so everything is written correctly. So therefore, we can check. So notice here, when I do that, I get x plus 6. So it has to be exactly x, not x plus 6. So therefore, no, they are not inverses of each other. So the answer should be no. Okay, and that tells me that I was correct. Okay, so here we have, in this case, we have a domain of 0 to infinity. We're going to check to see if these are inverses of each other. We're going to plug those in. So we're going to check that one next. So we go through, do the same kind of steps here, wherever my here we go. We're going to do this first. Actually, I'm going to go through and do this one first. So because it doesn't have a restricted domain. So we want to find f of g of x. And that just means we do 2 times 1/2 x. And that equals 2. 2 times 1/2, of course, is just 1. So it's just x. So this one would be yes, they are inverses of each other. Okay. Now we could do g of f of x, which would be, instead we do 1/2 times 2x. So we plug in the other one in there. And that just equals x. So of course, whether we do it one way or the other, if we get a yes, it should be yes. If we get a no, it should be no for both. So we should be able to see that. So now we're going to go to the restricted domain examples, and then I think that should be it.